Right, in this video we will be learning about long division with calculus instead of long division with just numbers and arithmetic. At the end of this video you'll be able to use a long division to evaluate an integral. Alrighty, so when might you use long division? Well, sometimes if you see an integral and you're not sure how to evaluate it, long division is a trick that we can use. When would you use that trick? If the degree of the numerator is greater than or equal to the degree of the denominator, you'll perform long division on the integrand before evaluating the integral. This will set us up into a problem that we are able to actually take the integral of. So we're just going to jump right into examples. Notice it says to evaluate the integral, and that's 4x over x minus 1. And we know that if we tried to do a u substitution, usually we would let u be the denominator, but then I'd get du as 1. And there's an extra x up top there, so I know that that is going to give me an issue if I try to do something with it. So since the degree of the numerator, so the degree of the numerator is 1, and the degree of the denominator is 1, if those are equal or the top is bigger than the bottom, we can perform long division. So I'm going to actually perform long division on this right now. So I'm going to have x minus 1 into 4x. So we're actually going to be doing long division just like you would do division on numbers. So I'm going to say x times what would be 4x. It's going to be 4. And then we're going to take 4 times both parts on the outside. So 4 times x will be 4x. And then 4 times negative 1 is going to be negative 4. And then just like in normal long division, we're going to subtract. So we'll subtract and subtract. So 4x minus 4x will be nothing. And then when I take nothing minus negative 4, this is going to turn into plus positive 4. So that will end up being 4. And then notice x will not go into 4 because you can't think something times x to give you 4. So we are done. This is going to be our remainder. So the way that we are going to rewrite this problem is going to be x minus 1 went into 4x 4 times plus the remainder. The remainder is 4 over what I was dividing into, which was x minus 1. So that is what my new integral is going to look like. We're going to split it. So I'm going to have 4 plus 4 over x minus 1. And then from here, we can just take the integral of each part separately. The integral or antiderivative of 4 will be 4x. And then on this one, what we're going to have to do, since we have a denominator, I am going to now do a u substitution, which is x minus 1. du will equal 1. Notice I have a 4 up there, though. So to make that say 1, I'm going to put a 1/4 on the inside and a 4 on the outside. So now I have 4, and this is now du over u. And we know the integral of du over u is ln. So 4 ln of u. And then we still have that 4x plus c. So that will be the integral of that problem. Okay, problem number 2. We have 2x squared plus 7x minus 3 over x minus 2. Again, we would like to be able to take the integral of it, but the way that it's set up now, if I tried to do a u substitution, that just would not work out, so I'm kind of stuck. But I do know that notice that the degree of the numerator is greater than the degree of the denominator, so once again, we are going to do long division. So I'm just going to go ahead and get my problem set up for that. And then I'll be thinking to myself, we just look at this first one, x times what would give me 2x squared? That would be 2x. And then we're going to take 2x times both of the outside numbers. 2x times x is 2x squared. 2x times negative 2 is negative 4x. And then we are going to subtract. So 2x squared minus 2x squared is nothing. 7 minus negative 4 will turn into 7 plus positive 4, which will be 11x. And just like in normal long division, you bring down that next term. Right, now I'm going to be asking myself, x times what will give me 11? That will 11x, that will be positive 11. So again, we're going to take that 11 times both parts. So 11 times x is 11x, and then 11 times negative 2 is going to be negative 22. Again, we're going to subtract. 11x minus 11x is nothing, and then this will turn into plus a positive 22. So negative 3 plus 22 is going to be 19. That will be my remainder. So the way I'm going to rewrite this problem is x minus 2 went into 2x squared plus 7x minus 3, 2x plus 11 times plus a remainder of 19 over the x minus 2. Okay, then from here, since we have pluses, we're going to treat each part separately. All right, so the first part, the antiderivative of 2x will be x squared. The antiderivative of 11 will be 11x. And then just like we did on problem 1, we're going to do a u substitution. U will equal x minus 2. du is going to equal 1. I needed a 19. So I just need a 1, so I'm going to multiply by 1/19 on the inside and 19 on the outside. So this will turn into 19 du over u, and which will be an ln problem. So I'm going to have x squared plus 11x plus 19 ln of u, which is x minus 2, and then plus c. All right, problem 3, same type of issue here. If I went to go do a u substitution, it just would not work at this point in time. And I do notice that the degree of the numerator is greater than or equal to the degree of the denominator, so I should be good with this. So I am going to go ahead and do some long division once again. And so then x squared times what would be 2x squared? That would be 2. So take that 2 times both outer terms. 2 times x squared is 2x squared. And then 2 times 16 is a positive 32. We're going to be subtracting. I'm going to put a 0 up there. 2x squared minus 2x squared is nothing. 0 minus 32 is going to be a negative 32. So from here, we know that x squared plus 16 went into 2x squared 2 times, with the remainder of negative 32. Okay, and then I'm going to go ahead and separate them into 2 parts. So I'll have the integral of 2 plus, actually I'm just going to put that minus right up front, minus the integral of 32 over x squared plus 16. Okay, now from here, the antiderivative of 2 is just 2x, and then I need to notice right here that this is actually set up as an arctan problem. So we are going to actually be using arctan for this one. So on this one, we want to identify our u would be x, our du would be 1, but we have a 32, so I'm going to multiply by 1 over 32 on the inside, 32 on the outside, and then my a, if 16 is a squared, a would be 4. So remember in my arctan problem, I'm going to bring down that 32. In an arctan problem, it's going to be 1 over a, arctan u over a, so x over 4. So if I just simplify this a little bit, I'll get 2x minus 32 times 1/4 is 8, arctan x over 4 plus c. Hopefully now you can use long division to take the integral of an integral.